Okay,
784.
we're going to be shifting gears and going from the binomial distribution now to the normal distribution. The binomial distribution is what we call a discrete distribution, right? The probability x equals 5 or 6 or 7, discrete jumps, okay? The normal distribution is different. The normal distribution is a continuous distribution, first of all. And this is our bell-shaped thing that we looked at a few chapters ago. So there's a couple things that you need to know. With the normal distribution, it's a smooth, continuous, bell-shaped distribution. And in particular, you need to know that it is symmetric. That's very important. So in addition to being smooth, continuous, it's symmetric, and the mean is right in the middle. Okay? This is a normal distribution. All right, now you can have a bunch of different pictures. So this is one example of our normal distribution. You could have another one that looks more like this. Okay, and that's also a normal distribution. Or you could have something more compressed. Okay, and these are all normal distributions. So what gives its particular shape are two things. So there's two things that you absolutely have to know whenever you're working with the normal distribution, and that is what's the mean and what's the standard deviation. Okay? It's always symmetric, it's always continuous, it's always smooth, all right? But what particular shape we have is dependent on these two things. What's the mean and what's the standard deviation? All right? Okay, let's do an example. Let's say we have a test and it's normal. Something like, let's say the mean of our test is 70. Let's make it really nice. And the standard deviation is 10. Okay? So let's just draw out this normal curve. So I'm going to draw it out. If the mean is 70, 70 is right in the middle. That's what I have so far. Okay? Now, if you guys remember the empirical rule, or the normal rule, it's that approximately 68% of the data fall within 1 standard deviation above and below the mean, approximately 95, 2 standard deviations up and down, and almost all of it within 3 standard deviations, okay? So let's just check off 3 standard deviations. So if I go up 1 standard deviation from the mean, I will be at what test score? 80, great. Go up another, 90, and let's go 3 standard deviations, we're at 100, okay? Let's also do that on the other side, so 60, 50, and 40. Okay? So pretty much all the scores should fall within 40 to 100. You might have some extreme values, but pretty much all of them should fall within 40 to 100. Okay? Okay, now, here's the thing that we need to know. You could have any normal distribution in the world, and you can transform that to what we call a z or standard normal distribution. Okay? So now let's take a look at what we mean by a z or standard normal distribution. Okay? What makes your normal distribution a standard normal distribution or z distribution is the mean is equal to 0, and the standard deviation is equal to 1. Okay? So you can take any normal distribution and make it a standard normal distribution, which is just a normal distribution with mean 0 and standard deviation 1. All right? How do you transform a normal distribution to a standard normal distribution? Well, it's something we've already learned in our class. Z. Okay? What was my formula for z? How do I do a z-score or z-value?
over something.
Yes. It's x minus the mean over the standard deviation, right? Or x minus x bar over s. Great. Okay? So if this formula really works, then if I draw my standard normal distribution right underneath it, what do we say the mean of the standard normal distribution is? 0, and then it should go 1, 2, 3, right? -1, -2, -2. Okay? So, for instance, take the test score 80. That should go with 1, right? Can we check that real fast? What would I do? What's my z-score say? Z equals 80 minus the mean, 70, divided by the standard deviation, 10. Well, 10 over 10 is 1. Okay? And I'm going to get in the habit of putting my z's to 2 decimal places. Okay, and you'll see why in just a second. But this is z of 1. Okay? All right. So just know that you can convert any normal to a standard normal using your z formula. Okay? The next thing you absolutely have to know is finding area under the z curve. And that's what your chart is used for. Okay. Finding area under your z curve, your standard normal curve. Okay, well, if 0 is in the middle, I can ask you any question, all right? So let's say I want to know, let's say this is about 1.25. I want to know the area to the right of z equals 1.25. Okay? Let's say that's the first question I want to know. So what is the area to the right of z equals 1.25? Okay, pick up your chart. Now, how do I read this chart? Well, you have your z values on the left, and then it goes out, it's kind of like a stem and leaf. It goes out an extra decimal points as you look across the top, okay? So you have a positive side and a negative side. Well, we're on the positive side, okay? Now, if I go down to z equals 1.2, so if you follow down on the positive z value chart and go down to 1.2, then you're going to need to scroll over to 0.05, okay? And that will give you 1.25. Is everybody with me on that? So on the positive z chart, go down to 1.2 and then go over to 0.5 and just read off what that value says. What does it say? 0.8944. Okay. So again, if you look at your chart and you go to 1.25, it says, what did you just say? 0.8944. That's what it says. All right? But now if you look at the bottom of your chart, what picture is it shading? Is it shading to the left or is it shading to the right? To the left, okay? What question did I ask?
Right.
Area to the right. Does everybody see that? So whenever you're looking at this graph or these tables, it's always giving you area to the left. So if this question I said, what's the area to the left of z equals 1.25? Great, it's 8944, okay? But it's asking area to the right of 125. Well, the good news is this whole thing adds up to 100% or 1, okay? So if this area here is 0.8944, then what does this area here have to be?
The rest.
1 minus 0.894. Okay? And that's it. So do 1 minus 0.8944, and that's your answer. 1056. Okay? It's going to take a little bit of time, but hopefully within a day or two, you should be able to get any area under this curve. Any picture that you could come up with, you should be able to figure out. Okay? All right, let's start off with an easier one. Let's do a common sense one. Let's say I have 0, and I want the area to the left of 0. Well, without looking at the chart, if this whole thing adds up to 100% or 1, and we know it's symmetric, then what would the area of 1/2 have to be? 0.5, okay? So this area should be 0.5. And again, get in your habit of writing your areas to 4 decimal places, but your z-values to 2 decimal places, okay? Can you guys check this in the chart to make sure that it is 0.5? So where would you go? Z equals 0, 0.0, and what does it say? 0.5000, right? Okay, now I'm going to start drawing pictures, and I'm going to have you go to the chart and figure it out. So let's say here's 0. Let's say z is negative 2.23, and I want the area to the left of negative 2.23. Okay? Figure that one out. Area to the left of negative 2.23. It doesn't get easier because I gave you area to the left, right? Your chart is set up for area to the left. So you go down to negative 2.2. You go over to 3, and what is the value?
0.0129.
0.129. So this area is 0.129. Okay? I look up negative 2.23, and it gives me area to the left. So it's done for me. All right. What if I asked you this question? Area to the right of 2.23. Now, let's use common sense before we go right to the table. I just did area to the left of negative 2.23, and now I'm asking area to the right of 2.23. It's symmetry, right? It shouldn't, this picture, if everything is symmetric, that area be the same as that area? It should, right, if it's symmetric? So if this is 0.129, what should this one be?
0.129.
It should also be 0.129. Okay, but if you look up 2.23 in your book, does it give you 0.129? No, it gives you area to the left, right? So go ahead and look up 2.23 in your book. It gives you 9871. All right, so if this all works out, 1 minus 9871 better be 0.129. So go ahead and check that. 1 minus 0.9871. Okay? Because it's symmetry. So as you guys get better and better and more advanced, if I had to look up the area to the right of 2.23, I might just cheat and look up the area to the left of negative 2.23 because my table's set up for the left, and I know symmetry works. Okay? All right, let's do this area. I want the area between 0 and 3.01. Okay, that's a terrible drawing because 3 should be way out there, but still. I want the area between 0 and 3.01. And how did you get that?
Find it for 3.01 and subtract the half.
Right, subtract 0.5, right? Okay, so great. So hopefully you looked up 3.01, which is 9987. So we have 0.9987, but that's for everything up to 301, and I need to subtract off this half, right? So minus 0.5, and you get 4987. Okay? And it's okay if you're confused and still trying to figure it out. It just takes some time, all right? It's going to take some time to get this. Next question. Area to the right of z equals negative 0.23. Area to the right z equals negative 0.23. I highly recommend on all of these you draw them first. So 0's in the middle, negative 0.23 is just a little bit over here, and I want area to the right. Okay? If I look up negative 0.23 in my chart, it's going to give me area to the left. So again, I'm just going to have to do 1 minus that area. So if I look up negative 0.23, it is 4090.4090. So that's this area. But I want this area, so I'm going to have to do 1 minus 0.4090. 591. So this answer is 0.591. Question?
Would it have been faster if you had just done 0.23?
Yeah, probably. But I wanted area to the right. So if you look up negative 0.23, it gives you 4090, which is area to the left.
You just do the positive 0.23?
Oh, you mean the opposite? Yeah,
Yeah.
sure. You could do that too. Using symmetry. So there's not one way to do this. You could do it a bunch of ways, but whatever's easiest and makes most sense to you. Okay. All right, what is another thing that we looked at where if you added up all the area, it added up to 1 or 100%? Something we just did recently. A probability distribution, right? So this normal distribution can also be used as a probability distribution, okay? And instead of saying what's the area to the right of z equals 0.23, the question looks like this. The probability that z is greater than 0.23, okay? These mean the same thing though, okay? So the area to the right of z equals negative 0.23 is the same written like this, okay? So this is the same as this. It still means find the area to the right of negative 0.23, okay? All right, I'm going to use this notation now on a couple of problems and see if you guys can get these. All right, question number 1. What's the probability that z is less than 2.26? Right? What that should mean to you is I want the area to the left of 2.26. So draw a normal distribution. 0's in the middle. 2.26 is right here. And I want the area to the left. Should be a relatively easy problem because all I have to do is look up 2.26 in the chart, right? And it gives me 9881. Yep. So your answer is 0.9881. Okay? You guys have to spend some time, draw any picture, and be able to get the area back, okay? Because as we move on in the next couple of sections, we're going to take this for granted, all right? I'm not going to give you 5 minutes to try to figure out an area. You should all be able to get it instantaneously, and then we move on, okay? This, finding the area, is going to be one little subpart of a much larger problem coming up. So spend a lot of time getting this section. Do not fall behind this, okay? All right, let's do another one. What's the probability? If you can get this one, you should be able to get them all. Let's say negative 3.01 is less than z is less than 1.29. Okay? So what does that mean? I want the area between negative 3.01 and 1.29. So draw your graph. Negative 3.01 is way out here somewhere. Here's 0 right here. 1.29 is probably right here. And I want this area. How am I going to do this problem? If I look up 1.29, what does it give me? 9015, right? So this whole area is 9015. But that's more than I want, because I don't want to the left of 301, right? So what am I going to have to do with that to the left of 301 area? Subtract it off, okay? So now look to the left of negative 3.01. That's 0013. So I have 9015, and I need to subtract 0013 to get my answer. Okay? So 9002 should be your final answer on that problem. Okay? Play around with it. Invest the time in being able to do the areas. Really, really, really invest time on that. Okay? Questions on this? Okay, good.